Holy crap, did it just desolder itself? I think it's desoldering itself. One end of the coil goes to the antenna connector, jumps to the diode. The diode is our audio path, and this comes out to the headphone. One of these days I'm going to fix the squeaky chair on the stream. So if you want one of this rev, it's available to ship now. Oh yeah, can't do that here. Can't do that here. Gotta do that in the other part. Boy, I've got that heatsink hot. Like hot. Like feeling hot. I mean, this is not going to be a showstopper that stops me from developing this. If I got to deal with a line of garbage for this badass capability, I'll deal with a line of garbage. And the microcontroller trainer is a learning environment, experimentation environment, development environment. You come up with what you want to call it. Hey everybody, my name's Josh. Welcome to Project Blue Smoke Monster. This is kind of a special edition happening right now. I had not planned this stream, but we'll get into that. When I first started experimenting with electronics, I was like 9 years old. And how does a 9-year-old get into electronics? Well, that's easy. They start tearing things apart. And that's exactly what I'm going to be doing today. Tearing something apart that's probably older than I am. What's up, Jay? What's up, TMKDK? Thanks for joining. This is going to be a fun little teardown stream. So when I was like 9 years old, I'd ride around the neighborhood, and anytime somebody would throw away a piece of stereo equipment, I'd schlep it home and tear it apart and learn how things worked. And that's what we're going to do today. I've had this here, meaning to do this stream for months and months and months now, probably since fall. And this giant, monstrous piece of equipment has been taking up space on the floor. And I'm finally doing a little lab organizing, and this thing's got to go. But we're not just going to throw it away. We've got to do it honors and tear it apart and scrap the parts and save from it its beating heart. So I thought we'd do that live with you guys today. So here's what we've got. This thing is pretty cool. It is called an Electrophonic. I'm guessing that's the brand. An Electrophonic solid state total music system. We've got a turntable. We've presumably got an AM/FM multiplex stereo receiver. We've got an 8-track player and recorder. Lots of really cool 1960s, 70s vibe going on here. Hey, Starch Face. So, first thing we're going to do is let's see if this thing even comes on. I haven't tried. I'm going to, for this one, reframe the video and get rid of the camera for me because I really want you guys to see this whole unit and not have me wasting any space. Just stand by for 1 second. Let's see here. I'm going to make myself just a teeny little thing in the corner here. All right, cool. So where is the pickup? You know, where is a lot of things? I don't know. This came from the trash. So let's plug it in and turn it on and see what happens. Hey, there's something. We've got, it says AM, but the turntable's turning. Yeah, 8-track recorder. Those are definitely going to catch on. Now you might, if you're as old as me, you might recognize this turntable. These things were everywhere. This is, I believe, made by BSR. This one assembly probably had 100 million different things using it. We've even still got a needle, a stylus on this, but we do not have the spindle, so that's gone. Let's see what else we've got. So, phono stereo, tape cartridge, nothing lights up there. Wait, all the way to the left. Phono stereo. Everything's dark. Tape cartridge. That says tape. AM. That's supposed to be FM, but doesn't light up. That's FM stereo, but doesn't light up. So yeah. We have automatic frequency control, rumble, scratch, 4-channel sounds. This is that good quadraphonic stuff. But yeah, we're going to take the screwdriver to this today, and the 8-track's in the front. You guys can't see it yet, but you'll certainly get a peek at it as we go here. I will be unable to chat. I can read your chat, but I can't type back because I don't currently have a keyboard hooked up. There's a whole bunch of other things going on in the lab here now. So we have no intention of trying to repair this. This is completely intended for the purposes of tear down. So that's what we're going to do. We're going to just start getting at this thing. And I'm expecting this module to lift out. There's a few surface screws here holding a bezel on. And now it's unplugged. Let's do that first. But the goal with this video is just to see what kind of useful things we can scrap out of this before it gets thrown away and out of my lab because it's taking up way too much space. There's no collector value. There's no audiophile value in this thing. It's not in good enough condition for that to even be a consideration. But there is educational value in the teardown for me and for you and for others that might watch this down the road. So that's where we're going with it. Yeah, it's very likely that those are just burned out bulbs. So let's see what we got here. We got knobs we'll pull off, some faders. You got a lot of the old school faders, right? The linear potentiometers. Let's see, does this thing come out? Oh yeah, there's the bezel. There's the bezel. There could be bugs crawling around in this thing for all I know. But yeah, bezel comes off. It's got that old 60s, 70s brushed stainless thing going on. But yeah, Electrophonic solid state IC FET circuitry. We'll keep an idea. Those knobs are for spare parts. Yeah, they could be. Nothing that I'll work on will ever need those. But yeah, we're going to get at it. So we can kind of see in here, there's the tuning set up. There was the light for the tuning slider. See, we couldn't even see any of this. We didn't know this was under here. I remember looking at this. Spoiler alert, I had powered it on once before. I haven't done any taking apart or diagnostics, but I noticed that it was dark and I didn't see an FM dial. So I was curious if it was going to be under that. And sure enough, there it is. But that's kind of cool, right? So that pulls that out. Now I'm betting the phonograph comes out in a similar manner. Although I'm betting the screws for the bezel are probably on the under. Oh wait. I was gonna say on the underside, but nope. I found some in the back. Things that I expect to pull out of here. Big honkin' transformer. Yeah, that's probably the one thing I'm certain of. Other than that, I don't know. We're just going to look and see what happens. Maybe I'll find something cool that needs to find its way into a project, right? That sometimes happens. Let's see if this thing will lift up now. The bezel seems like it wants to come up. And yes, things will break during this process. That's okay for this particular piece of kit. We are not trying to save anything. Alright, well, that's not wanting to come off. So let's see if we can get this other unit also still seems like it's just set in there and can come out if I have the right size tool to get at it, which I'm not sure that I do. So this may become a needle nose plier disassembly job, as they often do with this kind of gear when you're 12 years old, right? That's how it was for me. Looking to see what I've got. Yeah, here's some needle nose. I'm not going to go dig out a socket set. That's too much work. Maybe. Maybe I will end up digging in a socket set. Well, that doesn't want to come easily. Let's give you a look at the front of this thing. Boom, there she is. There's the 8-track. Record. Pretty cool. Ooh, there's a table under this. Service information. Ooh, I think this thing might be newer than I was. Well, I don't know. It might be a little newer than I thought. Service information, model GR8213E. Changer 6200C. And then we have what looks like a date code. 7/74. So early 70s. Little different, little newer than I thought it would be. Let's give her a proper flip. Hey, well, you know, there is a saw. There is a saw nearby. We'll save that for if it comes down to it, all right? These 2 screws here are probably what's holding the turntable changer in place. We'll get at those in a minute. There's a certain amount of fun in just tearing something old apart to look at how it's built. I'm going to make some predictions. I'm going to bet this is a single-sided circuit board. You know, that brown phenolic? I'm almost positive that's what we're going to find here. I could be wrong, but we'll see. I've not peered into it yet. There are other screws I can't get to right away, but let's see if I can get those out. Oh yeah, that'll fit. Just something about where those are placed and how they look lead me to believe they're what's holding that turntable in. But I could be wrong. I bet I've removed hundreds of these turntables from things over the years. Sometimes they were large cabinet systems that I would drag home down the alley or in a wagon, you know, 6 foot long, 3 foot tall, wood. I've pulled more than one of those home at 10 years old. Okay, that seems to be holding a little weight. Let's see if that turntable comes out when I flip. Ugh, no, there's still something holding it in. I'm not sure what. Glue, maybe. Part of it's coming out. Ugh. There we go. There we go. All right, let me set that aside. Flip this over. This is progress. So here's the turntable unit. I'll flip it upside down. You can kind of see the mechanical aspects of this. You've got probably an AC motor here that's used to turn, drive the belt that turns the turntable, and then you've got all the mechanics here for all the changer system. This is something I always found really interesting as a kid. Look at this, the wire ripped off when I took it apart, but look, they have integral RCA jacks and cables that they used. They got their term phono jack for a reason, but these are RCA connectors. But yeah, that's kind of cool. Very assembly. So she's out of here. That's good for the recycle bin. We've got, look there, amphenol connector for power. And then there are the internal RCA cables that I ripped the tips off of. But yeah, very cool, very cool. And down here, we can see the mechanism for the 8-track. Made in Japan. Morse Electro Products Corp. Serial number 20647. Made in Japan. That right there is pretty cool. Oh yeah, very sweet. All right. Well, the other thing that should happen is this seems to want to come off the bottom because I think I got the right screws out of it. So let's peel it apart. Let's clip a couple wires here. Go into the 8-track. One more. And we'll get this thing. We'll start explaining a few more things about what we're looking at. I'm going to twist it here. There's some wires hooked up to the back panel that I haven't yet disconnected. Alright, sweet. So what do we have here? This is awesome. So, like I mentioned, or like I predicted, here's our big honking transformer. Here's our AM/FM radio. In fact, I can see, here's the tuning dial, which, I wonder if it's still moving the slider. It's still moving the slider on the front, so that's cool. We've got the ferrite bar, which is the coil used for the antenna. We've got an open air variable tuning capacitor. That's gold right there. Multi-position Alps switch. Not a lot else that I would scrap out of here, but the ferrite bar I'll take. The cap for sure. The transformer for sure, and the rest of it's probably just fun. But this is pretty typical of what you'd see. You can see some twin lead mixed into this wiring bundle that goes to the antenna connector for the AM side of things. And you can see a little bit of that right in here, the twin lead cable. So that's kind of cool. How'd they make sure that the turntable had the right speed? It actually had a mechanical selector, and this one would in fact support 7,800 RPM. So 33 1/3, 45, and 78 were all supported on this player. Yeah, this is sweet. And I was right. Look, single-sided PCBs, that brown phenolic. It's exactly what I expected to see. Cool, cool, cool. Carbon composition resistors all over the place here. You got some more modern ones, but a handful of carbon comps. Very traditional linear power supply. Strip board. Can you see that? You can't see that yet. Here's a little terminal block. Barrier strip, whatever you'd call that it's built on. So yeah, this is badass. Badass. Cool little teardown. Alright, well, let's take some things out of here that we think we'd like to keep. Suitably sized pulleys to select speeds. Yeah, it was not a precision thing. It was basic math and close enough. Later turntables, or higher end turntables, did more accurately, through the use of encoders, measure the rotational velocity. Oh, man, that thing's in there. There we go. They'd measure the rotational velocity so they could be tuned precisely to the speed, and they would have feedback. But yeah, back in this day, there was no feedback. There was no checking, is it right? It was close enough is all you're going to get. Let's get some nippers out here and cut some cables so I can free some parts from one another here. This really takes me back to my childhood. I spent, I don't know how many hundreds of hours doing exactly this. All right, cool. I'm going to put that aside for 1 second, and let's take a look at this 8-track deck. So this is pretty standard fare for an 8-track system. You've got your rubber band, and you see how stretched that is? This thing's, I mean, it would turn, but yeah, it's labored. It's done. And all the dirt that's actually physically inside the case is kind of amazing. But you'd have your track selector here in the front, which is where these switches go. You'd be able to push it, and it would trigger, the toggling. And what would happen on these is the head here actually moves up and down for track selection. In fact, I can pull that rubber band off of there. I might even be able to pull this pulley. We'll have to see if it's tight or not. Yeah, it's pretty tight. But that would move up and down, and that's your playback head's right here, and your recording head's probably right over here. But yeah, this is sweet. And then actually, do you see this? You can probably see it. Let me see if I can get a little tighter on it. Right here. This is in line with the tape feed. There's a conductor and another conductor. And that's actually a switch. They would, and I totally forgot this was a thing until like right now I'm looking at this mechanism. There was a piece of metallized film tape on the actual, the magnetic tape that would, you know, it was electrically conductive like a wire. And it would spin across, and when it would hit it, bam, it would slap it, and it would trigger the 8-track to transition. Just like you had pushed a button. So it's a track change kind of thing. Because an 8-track, there was no rewinding or fast forwarding. It was one solid, endless spool of magnetic tape, and it would just keep going and going and going. So it would hit that metal strip, trigger a switch, and then it would chink, 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 you know, from track to track to track. And that's how that worked. But that was the trigger. Very cool. So there's nothing in here I'm going to tear out. It's not worth my effort to save that DC motor. But that was kind of cool to get apart. But where I'm going to really focus my attention on is the remaining unit here. This bad boy right here. I want to save some things from this. And let's flip it over. Oh, that's what we saw when we flipped it over. Okay. So we've got the mechanicals. Those pots, those things are bound to be way noisy. I don't have any desire to try to scrap those out. Really, I think all I care about is those couple of parts. Transformer would be nice. This bar would be nice for some radio projects, and definitely this air variable capacitor. That is very cool. Well, let's start cranking at the things we care about. They liked to glue, and I'm slightly out of frame there, but you'll see me in frame in a second. They like to glue a lot of these screws with like waxy kind of glue to keep them from backing out. But yeah, see that right there? You can pull this out of here, and I'm gonna do some very intentful clipping of wires because I want to keep this usable as much as possible. Do that. Clip that, and we'll do measurements, you know, down the road to figure out what each of those wires' role is. It's a pretty traditional ferrite core, but super awesome for AM radio. More likely is what they're using that for. So that's a save it piece. What else are we gonna save out of this thing? I told you this air variable capacitor, faux show. That's like number one thing I want in this whole project is that cap. Let's see if this screw pulls out this board. I'm not sure what that screw does. Doesn't seem like there's a lot holding that in there. I'm going to go ahead and clip the tuning wire. It loosens that up. We got a little bit of here, so that may just be wires. Clip these wires out. Cool. And it's okay if the circuit board breaks. In fact, I'll be shocked if it doesn't. But we're just going to try to get the module free. Yeah, there we go. There we go. What are we spinning on? It's almost like there's... Oh, yeah, there's a screw down under that. Okay, cool. So what they did... apparently... is I think the cap is actually floating somewhat. So they installed the capacitor, or they installed the board, then they installed the cap. Oh yeah, there we go. Here's one, here's two. Awesome. Tuning dial off, and I won't need that dial. And yeah, 2 screws. Okay, cool. We just about freed the cap. Poor board. You know what? This board was from the 70s. It's okay. It's not an Apple I or anything. Alright, let's see if this thing will come out now. Oh, we're so close. So close. Ugh. Yep. Here goes. Here goes. Clip that wire. Clip that wire. Bingo. Boingo. Bango. Bongo. Boningo. Whatever. Ha! Air Higher variable capacitor has been freed. We'll leave that PCB on there for now. But when we go to use this thing, these terminals right here are probably all we're going to need. But that is a really nice cap. That'll come in handy. That's probably like 12 to 100 picofarad. I'm guessing. We'd have to measure it. But that is a super, super reusable piece for radio project. My desoldering iron looks like wire cutters. Absolutely. Yeah, when you're doing this class of a teardown, there is no desoldering. There's no need for that. Date code 7408. So, fall of 1974. I see the FETs that they're talking about. This is early FET technology. I'm going to pull some of these other boards out just to look them over. And if something jumps off that we want to save, we will, but not highly likely. I don't know. We're going to get that one out. That screw seems a little not giving it up. But, you know, being that they're old single-sided phenolic, we can just do this and break the corner off. And it'll come right out. So, plop those. And, you know, this is exactly how the teardowns would go when I was a kid. I didn't know what any of this stuff was. It's just a matter of, hey, let's get it free and let's look at it and let's learn something. And that's exactly what's happening now, is we're going to learn something, you know? I can tell by looking at this board. Let me get a little tighter on it. This is a lot of your tuning circuitry for the radio. You can see all of these inductors that were adjustable. So this is probably some sort of super heterodyne receiver. In fact, look right in there. Those appear to be, they may be germanium diodes. So that may be the detector for the AM radio circuit. And there's two of them in there, so that's kind of curious. But yeah, pretty cool stuff. We could look up that chip, the F76TPC. I'm not familiar with that one, but I would bet anything this is pretty much an AM/FM tuner board. What else we got going on in here? I'm curious to see what the FETs were they were using in here. NEC Charlie 1098 Whiskey 32 Alpha is what they look like. They're called. Those are kind of cool. You guys can't really see them. They're tied to this. Let me zoom out a little bit. They're tied to this aluminum heatsink right here. But yeah, there's 1, 2, 3, 4 FETs. Oh, dude! I just saw something out of the corner of my eye. Look at this. You guys are gonna like this. Let me zoom in on it. This is how they mated up things to other things. Oh, look at that. Look at that plug-in connector. This has still got I come from a land of vacuum tubes written all over it. That's basically a tube socket that they've put a plug on and a wire. And now they're not using it for what I'm going to assume was the intended purpose. But that's the perfect transition into, hey, I'm a connector that can be a pluggable. But that screams from a history perspective of my grandfather was a vacuum tube. I mean, it's the same pin size, the same type of layout. Yeah, that's exactly what that is. They still had tubes on the mind. Oh, this is really cool, guys. All right. It even smells like 1974, right? Think of how much Stevie Nicks came out of this thing. It's probably got trace amounts of drugs on it. Alright, cool. Yeah, I'm going to see if this board will loosen up here. That's got the FETs on it, so I'm going to have to unscrew them from the little heat spreader here. Now, they've got little mica sheets behind them that they were using to keep them electrically isolated. So those will fall out. I'll tell you what, this is probably my favorite kind of stream, honestly, is the teardown. It just takes me back to my childhood. All right, cool. That looks nearly free. me see if I can get that one last screw out. All right, sweet. Let me pull that board out of there. Oh yeah. Let's clip some wires. I mean desolder some things. No, I mean clip some wires. This is not a repair video. This is a scrap it video. Now something that I see in here, and I'll point it out. Some of these cables, like this one that I just pulled the wire off of, they're actually shielded multi-pair. So see, there's 2 conductors in that, and then it's got a shield on it. This is likely carrying an audio signal, and they were shielding it to keep the, the RFI out of that cable as much as they could. I've seen a lot of that in these over the years. It was a very common technique. There's a lot of cables to clip here. It's very easy to reuse these transformers too. Take a measurement, see what they are, throw a bridge rectifier on the thing, and go to town. Cool. So this is likely an audio amplifier stage. And those are the FETs that were being used. Yeah. We have, and I'm going to make some way assumptions here, guys. I do not know any of this to be a fact, but just from the things I'm seeing, the evidence I'm seeing. We have 2 of one type and 2 of another type. We have an NEC Alpha 636, and it says Mike 2 Yankee Alpha. We have 2 of those, one on either outside here. And then on the inside, we have an NEC Charlie 1098 Mike 39A, Mike 32A. I think those top are the part number. I'm going to guess this is some sort of a push-pull amplifier. Am I sure those are a FET? The only reason I'm saying that is because they badged on the top of this thing that it was using FETs. So I am making best approximations. I have not looked these parts up. There's a cool little transistor heat sink that I just pulled off. I see another one right here. That's something I'm going to keep. Those are some of the random things that you get scrapping something that, they just come in handy when you're doing a project. Yeah, very cool. In fact, those transistors have long enough leads. I'm going to clip them out of there. We might run a test on them and see how they read. See what kind of gain they have. And yeah, just exploratory stuff. There's 1, 2. But I'm going to bet anything that's a push-pull amplifier. Not anything. That's a quick little guess. How about that? I think it's a reasonable assumption. I saw what looked like some germanium diodes that I believe were being used as the detector for the AM. But again, these are all just guesses. I don't have the foggiest idea of the design of this unit, so we're just picking up or taking away what we can from what we see. This is not meant to be a full analysis as much as just having fun tearing some shit apart. But they did look like germanium diodes to me. I'm not real familiar. You said selenium or something? Do you mean like selenium? I'm not really sure. They had that germanium glassy look, but the black one, not the red one, if that means anything to you. Oh man, that screw is going to be a difficult one. There's another one of those terminal strips. Whenever you guys hear me talking about a terminal strip, this is what I'm talking about. They just free-wired the stuff to it, They could have made a PCB to hold all this, but it was just as easy to just, all I need is a couple of terminals and just run wires to it. So very cool. Very cool. There's a coil there, and here's just got another terminal strip on this side. A big one. There's a 1.4 thousand volt. I don't know if that's just a big cap or if that's like an MOV. It may just be a big cap. I see a couple of other terminal strips in here too. Other places, but not too many. Well, if I can't get that screw out, then I'm not going to get that power supply. And I'm not going to chase it. I'm not going to fight too hard for it. I can do this and let the tab break off. Oh yeah, terminal strips are absolutely probably made by hand. Come on, break off, break the tab, break the tab, break the tab. Ugh. Got it. All right, sweet. So here we go. I'm going to show you a few things about this transformer. For those of you who don't know how transformers work, this will be a perfect primer. All right, so what is a transformer? A transformer, this is a transformer in kit form, is two or more windings. You have what's called the primary side and the secondary side. This is the primary side. This is the secondary side. The primary on this transformer is going to be 120 volts. The secondary, you see I've got all these different cables coming out. I've likely got multiple secondary windings. And what happens there is I'll tap off of this transformer as, you know, let's say it's 120 volts in, you know, and we've got a different number of wraps of wire. It's coils wrapped around an iron core, and I'm going to show you that because I'm going to tear this apart and show you how it's made. But and when's the last time you saw somebody take a transformer apart, right? Done a bunch of those. But basically what happens is it's a ratio, and what will happen is the voltage will step up or step down through inductance as it does that. So inside one of these transformers, yes, I'm going to take it apart. You've got wiring for these different coils, or windings as they call them. But right there, that is your core of a transformer. Now, the windings go like this. And you've got basically this non-conductive paper-like material between all the windings. And then you've got these little slatted sheets of metal glued together. It comes in like this, like that. So one, then one, then one, then one, then one, and there's layers. And they put that all together and they glue it, and that's your transformer. So they didn't actually wind the wire around the core. They built the core around the wires. Now, these cores, God, I haven't disassembled one of these in 20 years. This is going to be fun. They can come apart. So, like, I'll break this off. I'm breaking that glue bond. And I'll actually be able to get up in here and pull it out. At least that's the theory. Let's see if I can get enough grip on it to pull it out of there. Come on. The first couple are usually the hardest. That one broke. We're going to get it though, don't you worry. This one or the next one. Or we'll take a saw to it. Well, that one broke apart, but we'll see if the other one can get it. And then there's just a little strip here. It's a filler. Right there. Let's see. It's just a little metal filler to make up the height. And then the next one comes out this way, and then the next one comes out this way and this way. Some cores are welded together. I've never seen that in consumer level gear, but that wouldn't surprise me. But your, Sears catalog 1970s stereo systems probably just had these glued cores. And you can see after 50 years, this glue pretty much just comes right apart. Let's see if we can get this one out. I really want to get this thing out of the core so we can disassemble this sandwich. Man, I'm so close. Oh, there it goes. There it goes. Came there. So see that little tab? That was down in here in the middle. And once you get it going and it starts to loosen up, then the disassembly becomes much easier, and they just typically just come right apart. Come on. Get out of there. Yeah, there we go. See, right there. And I could keep on going and make, you know, disassemble this whole thing and you'd see the coil. But I'm probably not that patient, so here's what we're going to do instead. Yes, this is going to be neat. This is either going to be where I do something really cool or where I lose a finger, and then YouTube bans this, or Twitch or whoever bans this kind of content. So yes.
I have to go pick up Ray now.
Okay, honey. Is he gonna stay?
Yeah, I'm tired.
That's fine. I'll see you in a few.
I was actually gonna ask you to go get her.
Oh, okay. Well, then give me a few minutes.
That's alright.
I can go. I just need a few minutes.
Okay, honey, you just stay here and be with her.
All right, then. All right. Coordinating the pickup activities. Let's see here. Now, that's a little bit. We're not all the way through there, but you can start to see. Get a little tighter here. You can start to see those coils, those wraps of wire. So like here's an example. I pull it out, and it's just side by side. It's enamel coated wire, just wrapped, and then it's got these paper layers between it. So you'll have an insulator and a wrap of wire, and an insulator and a wrap of wire, and it'll just keep going all the way through that coil. Now this is, I'm almost halfway through it, so we might as well cut all the way. See, look at that. Bald Engineer actually thinks I'm going to lose a finger. He just betted on it. All right. Okay, there we go. We're just about there. Got it. All right, we got it. All right, now, boom, right there. So you can see, and actually this visualizes it kind of nicely, that some of these windings are smaller and some are bigger. And, you know, you're going to have taps on these windings. But ultimately, those are all going to come out to each of these wires. And that's what's going to give you your different secondaries. So yeah, very, very cool. Very, very good typical construction of that sort of a transformer. If you guys want some really cool videos, watch on YouTube some of the guys rebuilding the armatures for motors and stators and things like that in the third world countries, and they're using these techniques that would never pass muster here in the States. But man, they get it done. All right. Well, that's kind of the meat and potatoes of what I wanted to show you. I scavenged a couple of cool parts, got a few neat things, and those will go into future projects. So specifically, this ferrite bar, this air variable capacitor, those are gold to me. A couple of really cool TO92, TO93 heat sinks for transistors. And we'll later on play with these FETs. See what they are, see what they do. And that was it. And now, most importantly, this giant thing that's in my way can find its way to recycling. So it can find another life, doing another thing, and that will be it. We can rebuild it better than it was before. Exactly. So stay tuned, guys. We're doing a bunch here in the lab. We're still working on the lighting. We're still working on getting things organized. I've been here like a year, and it's still a mess and not organized. I just took down the bank of shelves that were behind me, cut them in half, and slid them under the workbench here. So most of those little pull-out tubs I was using that were immediately behind me are now under the bench. That's super convenient. And I've been able to get the hanging parts bins back on the wall. They've been sitting in storage and I've been unable to get to them. So more stuff will be happening there. I'm also thinking about putting another workbench surface right here because, you know, there's never enough workbenches. That's all I've got for now. I appreciate you tuning in. It's been fun. I got a mess to clean up, but hey, it's out of my way, and we got to pick apart a piece of cool vintage audiophile entertainment technology. Thanks for watching. My name's Josh. This is Project Blue Smoke Monster. I'll see you next time. Holy crap. Did it just desolder itself? I think it's desoldering itself. One end of the coil goes to the antenna connector, jumps to the diode. The diode is our audio path, and this comes out to the headphone. One of these days I'm going to fix the squeaky chair on the screen. So if you want one of this rev, it's available to ship now. Oh yeah, can't do that here. Can't do that here. Gotta do that in the other part. Boy, I've got that heatsink hot. Like hot. Like feeling hot. I mean, this is not going to be a showstopper that stops me from developing this. If I got to deal with a line of garbage for this badass capability, I'll deal with a line of garbage. And the microcontroller trainer is a learning environment, experimentation environment, development environment. You come up with what you want to call it.